Hello, in this video I'm going to show you how to use the laws of averages to predict what's going to happen on the lottery. So this is a chart of frequency versus draw number, and we start with 59 numbers. Now, in draw number 1, 6 of the numbers get drawn. That leaves 53 numbers that have yet to be drawn, and these 6 numbers that have been drawn have now occurred once, so they have a frequency of 1. Now, we have 2 separate groups now. So there's going to be 2 different probabilities. We've got probability of any number being drawn is 6 out of 59. That's the same for every number. Now we multiply this by how many numbers are in each square. So there's 53 numbers that could end up in this square, and there are only 6 numbers that could end up in this square. So now we have the probabilities of how many numbers are going to end up in these next 2 squares in draw number 2. Now, if we round these numbers off to the nearest whole number, then the laws of averages show us that we're going to have 5 numbers in this square and 1 in this square. And that means that 5 of these numbers have gone from here. That leaves 48. 1 number's gone from this square. That leaves 5. And now we move on to draw number 3. So you might notice that the numbers have now spread out. The frequency range started off at 0, it increased to 1, and then it increased to 2. So the laws of averages actually predict that the numbers will spread out over different frequencies. So now there are 3 possible squares that numbers can land in. I'm going to calculate the probabilities of numbers landing in each square. So in this square, the probability is 48 times 6 over 59, rounded off to 5. So 5 numbers are going to drop from here to there. Now, when it comes to this square, there are 2 possible squares that numbers can drop from to end up here. And in total, there are 10 numbers altogether. So the probability of a number ending up in this square is 10 multiplied by 6 over 59, and when we round that off we get 1. So we've already got 6 numbers out, we don't need to calculate the probability for this square. But what we do have to do is subtract 1 from both of these squares. Now I can't subtract it from either one, we have to subtract it from both. So now each of these squares contain 4.5 numbers. Now because we're not actually defining what numbers they are, it doesn't matter if we have half of a number in a square. All that does matter is that we know how much is in the column altogether, so that we can calculate the next square. So if we repeat the process, I don't need to show you all the equations involved. It's pretty obvious that we're going to end up with 4 numbers there, 2 numbers there, no numbers there. And when that happens, this is going to change to 39. We're going to have to subtract a third of 2 from each of these squares. And that leaves us with a chart that now looks like this. Now if you add up all these numbers, all the white ones, it will add up to 59. So for the next draw, pretty obvious what's going to happen. But just to make sure we understand how it works, I'll just type out the maths involved. So that proves we'll have 1 number there. See, what I've done is I've taken the sum of, oops, I missed the number out. Yeah, that proves that we'll have 2 in that square. And then we move on to the next one. So if we took 4 out of here, that's 35. So basically I could go on all day doing this, working out where the numbers go. I forgot to subtract these numbers from here. So that's what it'd end up looking like when we got to draw number 5. And then for draw number 6, well, we've now got 7. I mean, 5 in this square. So by the time we get to here, it's going to be 1 number there. Most probably 2 numbers there. 3 numbers there. And then all these will decrease again. So you can see it's gradually spreading out. Now what I'm going to show you is an actual chart where the numbers spread out. So you can see, just how it works. So on this chart, for example, got 14 draws. And you can see how the numbers spread out over time and ended up where they are. So it's the same sort of pattern as what I predicted with the laws of averages. So basically the laws of averages predict that the numbers will spread out because as they spread out, it makes it possible for them to spread out further. So the more they spread out, the more they're able to spread out. And also, because there's more numbers in one column than another, they're more likely to fall from the column that's got the most numbers in. It's just laws of averages. So that's how you can use maths to predict that the range of frequencies that the numbers are spread over will increase over time. Now, I've slightly modified this sheet to include this section, and this is a section that basically outlines which numbers were most outstanding and why they were most outstanding. So for example, if we look at a range of draws from when the numbers went up to 59 to the most recent draw, then we can see that in the most recent draw, number 40 was most outstanding because it was the most overdue for its frequency. And in draw 2326, for example, number 33 was most outstanding because it was the most overdue. So I've had to expand this spreadsheet to include these new sections that basically look at every outcome. They measure how overdue each number was, or how frequent, or how overdue for its frequency it was. It looks for the one with the highest value, filters it out, and then when you get to this section, if this number that was filtered out is in the combination that was drawn, then the number goes onto this most outstanding section of the chart, well, of the number palace. And then when we get to the chart, if we're able to define which is the most overdue, the most frequent, or the most overdue for its frequency, then that information will come up just here. So if we look at a particular draw and we analyse it, then the analysis will show which of the numbers drawn was most outstanding and why. So for example, in the last draw you can see that number 40 was most outstanding because it was the most overdue for its frequency. Now, looking at this chart, you would probably think that 22 is most overdue for its frequency because it's nearest to that top right corner. However, when you look at the area of this square, well, of this rectangle, and compare it to the area of this rectangle, you can see that this one is bigger. So that means that this number, even though it's not nearest to the top right corner, it is the most overdue for its frequency. So I probably wouldn't have got that by looking at this chart before, but now that I've included this section based on my analysis of the numbers on this sheet, then now I can see. So for the next draw, I'm going to predict these two numbers for a start. So I've got 33, which is the most overdue, and 54, most overdue for its frequency. Now if we look at a chart for 33 and we expand it to include the full draw history, then the analysis shows us that the most frequent with 33 is 47, and the most overdue for its frequency to occur with 33 based on the full draw history is number 2. And that's just when we look at the 2 machines and 4 sets of balls that are currently in use. This is the current trend. Now if we look at 54, then we've got 19 is most frequent with 54, and the most overdue for its frequency to occur with 54 is 57. So if we predict that these numbers are going to occur because they are most outstanding, or because they are most outstanding with the most outstanding numbers, then hopefully I might win something tonight. So I'm going to see what happens if I put these numbers on. Now, the laws of averages would predict that the likelihood of any number falling in any of these squares depends on how many numbers are in the column that they would have to drop from to end up in those squares. So if for example I make a chart that basically is a copy of the main chart, and then I can use this to draw on and calculate the probabilities. So this one, I've got 3 numbers. In fact, just to make it a bit quicker, I'll just write a quick equation that will do this automatically. So we'll count the numbers, or basically the number of squares that are occupied, and multiply by the probability of each number occurring. Actually, that's going to be wrong because some of these have actually got 3 numbers in, but these are the probabilities just there. So I'm going to try that again. I'll just write how many numbers are in each column, I'll just count them myself. So basically you can see how it's developing. So they're the probabilities, and obviously if we rounded them off to the nearest integer, we can predict roughly where the numbers are going to land. Now, going back to the chart, let's just see what it will look like if these numbers came out. So it's not a bad approximation. It's not exactly in strict accord with the laws of averages, but it's roughly showing that it is possible for these numbers to land in these squares. So we'll see if this method of looking for the most outstanding numbers, checking the probabilities, is going to be successful in tonight's draw. So after tonight's draw, I'll see how it went. So that concludes this video. Goodbye for now, and stay tuned for the next one.